All right. Workbook 10, perpendicular lines and their equations. We're going to jump straight to question 2. Line L is represented by the equation y equals 5x plus 2. Line K is represented by the equation y equals 5x minus 7. And what is the slope of L? What is the slope of K? And is L perpendicular to K, y, or y not? Select a total of 3 answer choices. Select one choice for question A, select one choice for question B, and select one answer choice for question C. Alright, so it's asking for our slopes. So for A, what is the slope of line L? Alright, well, I remember that this equation, y equals 5x plus 2, is in the form of y equals mx plus b. And I remember that m is our slope, and 5 right there is in the spot where the m is, so our slope is 5. So then I'm going to go through here and I'm going to look for A with a 5. So question A is 5. So question B, what is the slope of K? And again, I'm looking at the equation y equals 5x minus 7. That is in slope-intercept form, and it's y equals mx plus b. So again, the 5 is in the spot where the m would be, which is our slope. So 5 is our slope for question B. So I'm looking for a B and a 5. Alright, there's question B5. Question C, is L perpendicular to K, Y, or Y not? Alright, so this is the symbol for perpendicular. It's an upside down T. And so when you see that, it is read as perpendicular. And so in order to check for perpendicular, you can do it 1 by observation or 2 by seeing if their product, or when I multiply them together, if it comes out to be -1. So let's check if it comes out to be -1. So the slope of L was 5 times the slope of K is 5. 5 times 5 equals 25, which is not equal to -1. So no, they are not perpendicular. Alright, the second way of checking is by observation. And by observation, I mean just looking at their slopes. They should be opposite reciprocals. So if I have a slope of 5, the opposite sign of 5 would be a negative, and the reciprocal of 5 would be 1 over 5. And where did this 1 come from? Well, any whole number is really written as a fraction over 1. And what a reciprocal is that means that the numerator becomes the denominator, and the denominator became the numerator. So it flipped on its end. So that's what a reciprocal is anytime the fraction flips over. So in order for lines to be perpendicular, they have to have opposite signs and they have to be reciprocals. And right now I can see 5 and 5. They're not opposite reciprocals. So I could have decided right then and there that they were not perpendicular. But question C, it looks like they were wanting the product. So C, no, because the product of the slope is -1. Okay, no, the product of the slope was not -1. So we're looking for a no. No, because the slopes are the same. That's also correct, because having the same slopes means that they're parallel. So there's our solutions for question 2. We're going to jump down to question 4. Triangle ABE has vertices at A 27, B 43, And E, 1, 4. A, which statements are true about triangle ABE? B, is triangle ABE a right triangle? Why or why not? Okay, so I'm going to scan at an answer choice for question A and see what they're asking about it. So the slope of EA is negative 1/3. Okay, so for question A, they're looking for slopes. And then question B, let's see. No, because none of the sides of the triangle are perpendicular. Okay, so they want to know if any of these angles, any of the sides are perpendicular, because if they are, that means that where they meet is a 90-degree angle. So where AE and EB meet, if they were perpendicular, that means that there's a 90-degree angle there, and that is the definition of a right triangle. You have to have one 90-degree angle. So let's go through and find our slopes for our sides and triangle. The triangle is ABE, so I'm going to start off by going A to B, just like it says. So I need the side length AB and then BE. And to finish it off, we need EA. Alright, so AB slope, we're going to count. Slope is the rise over the run, and I know the rise is the vertical distance. So from A to B, it's 1, 2, 3, 4. And it's negative because I went down. And run is vertical distance. So 1, 2, and it's positive because I went to the right. So negative 4 divided by 2 reduces down to negative 2. Remember that whole numbers are written as a fraction over 1. So BE, let's check that slope. The slope of BE, so the rise or the vertical distance is 1. And the run or the horizontal distance is 1, 2, 3. And since I went left, it's negative. So that's equal to negative 1/3. And now for EA, the slope is 1, 2, 3. And since I went up, it's going to be positive. And then I went 1 over, and that was to the right. So we have 3 over 1 is 3. But I'm going to leave it as this fraction form so I can compare opposite reciprocals when I check for perpendicular. So the first thing I'm going to do is go through and identify my slope. So the slope of EA is negative 1/3. No. The slope of AB is negative 2. Yes. The slope of EA is 3. Yes. The slope of AB is negative 1/2. No. The slope of BE is 1/3. No. The slope of BE is negative 1/3. Yes. Alright, so there's our options for A. And so now let's answer B. So the first thing we got to do is we've got to check for any perpendicular sides. So I'm going to take adjacent sides or sides that are connected. So AB to BE. So is AB perpendicular to BE? And then is BE perpendicular to EA? And then is EA perpendicular to AB? Okay, so I'm going to do this by observation. So the slope of AB is negative 2 over 1. And the slope of B is negative 1/3. Well, I can eliminate this already because they're both negatives. there has to be one positive and one negative. So nope, they're not perpendicular. So BE, negative 1/3 perpendicular to 3 over 1. Okay, so we're looking for opposite signs. So this one's negative and that one's positive. So far so good. And then we're looking for reciprocals. Did the numerator become the denominator, and did the denominator become the numerator? Yes, so this one is perpendicular. So we have a 90-degree angle right here. So yes, it is a right triangle. So I'm looking for a yes for question B. So yes, because AE is perpendicular to AB. No. Yes, because BE is perpendicular to AB. Did I title my things wrong? BE to EA. Yes, oh, it's right here. Yes, because EB is perpendicular to AE. And now you might be asking, well, you wrote EA and they have AE. It's the same line segment. They just started at A and went to E, and I started at E and went to A. It's still representing the same line segment. So there we have it. And same thing with EB and BE. All right, question 6. Quadrilateral has vertices at A -2, 1, B 2, 7, C 8, 3, and D at 4, -3. A, which statements are true about the slopes of the sides? B, which statements are true about the lengths of the sides? And is the quadrilateral ABCD a square? Why or why not? Okay, in order for it to be a square, we have to have the slopes of opposite sides are parallel, and then we also have to have that they're the same side length all the way around. So that's what it's asking us for here. So B, the length of DA is the square root of 40. Okay, so they're leaving it in exact form for the lengths, and for questions, for the answers for A, the slopes are left in fraction form. And then we're looking for question C. Yes, each side is parallel to the adjacent to it, and the lengths of the sides are all the same. Okay, so what is the qualifications for a square? And they have to have opposite pairs being parallel, and they also opposite sides being parallel, and the side lengths all being the same, and they have to have 90-degree angles. So that means that AB would have to be perpendicular to AD, perpendicular to all of these angles have to be perpendicular. All right, so let's start off by answering question A. What are the slopes? So we're going to find the slope for AB, the slope for BC, the slope for CD, and the slope for DA. Okay, so AB's slope, the slope is rise over run, so I'm going to rise, or vertical distance, 1, 2, 3, 4, 5, 6, over the horizontal, which is 1, 2, 3, 4, so 6 over 4, which does reduce down to 3/2. BC, I'm going to count our vertical for our rise, 1, 2, 3, 4, and since I went down it's -4, and our horizontal distance or our run is 1, 2, 3, 4, 5, 6, and -4, 6 reduces down to -2/3. And CD, we're going to have our vertical distance 1, 2, 3, 4, 5, 6, and since I went down it's negative, and we're going to go our horizontal distance, which is 1, 2, 3, 4. And it's negative since I went to the left. And negative 6 over negative 4 is a positive 3/2. And dA's slope is going to be our vertical distance or our rise, 1, 2, 3, 4. And our horizontal distance is going to be 1, 2, 3, 4, 5, 6. And it's negative since I went to the left. 4 over negative 6 reduces down to negative 2/3. Okay, so now let's go through and select our answers for question A. So A, the slope of dA is negative 2/3. Yes. Question A, the slope of dA is square root of 40. No. A, the slope of CD is 3/2. Yes. A, the slope of BC is 2/3. We have it as being negative, so let's see if we have that. A, the slope of BC is negative 2/3. A, the slope of AB is 2/3. No. A, the slope of CD is square root of 40. No. A, the slope of AB is 3/2. Yep. Okay, so now let's find our lengths. So for the distance formula, it is the square root of our horizontal distance plus our vertical distance, and we've already counted those out. So AB's vertical distance is 6 and the horizontal distance is 4. We already counted those out, so I'm just going to be using the numbers we found, and they're written down in our slope. The vertical distance is our numerator, the horizontal distance is our denominator. So AB's length is equal to the vertical distance squared plus the horizontal distance squared, which equals, alright, so 6 squared is 36 plus 4 squared is 16, and 36 plus 16 is equal to 52, and we keep our square root. So square root of 52. BC, the distance of BC is again the square root of the vertical distance, so negative 4 squared plus the horizontal distance, 6 squared, which equals the square root of negative 4 squared is 16 plus 6 squared is 36. And so we have the square root of 16 plus 36 is the square root of 52. And then we have CD. The distance is equal to the square root of the vertical distance, which is negative 6 squared, plus our horizontal distance, which is negative 4 squared. Alright, negative 6 squared is 36, plus negative 4 squared is 16. So the square root of 36 and 16 is the square root of 52, and we just add 36 and 16. So then the length of dA, what is its distance? The distance formula is equal to the square root of the vertical distance, which was 4 squared, plus our horizontal distance, negative 6 squared, which equals the square root of 4 squared is 16 plus negative 6 squared is 36, and we have equal to the square root of 52. Alright, so all of them are the same side length, so let's go through and select our answers for B. B, the length of DA is the square root of 40. No. The length of AB is the square root of 10. No. The length of AB is the square root of 52. Yes. The length of CD is the square root of 40. No. The length of DA is the square root of 52. Yes. The length of CD is the square root of 52. Yes. The length of BC is the square root of 10? No. The length of BC is the square root of 52? Yes. And there's our answers for B. So now let's look at our options for question C. C, yes, each side is parallel to the side adjacent to it, and the lengths of the sides are all the same. No, each side is perpendicular to the side adjacent to it, but the lengths of the sides are not all the same. Well, that one's not true because all of the lengths are the same. So I'm just going to eliminate that one right from the get-go. And C, yes, each side is perpendicular to the adjacent side to it, and the lengths of the sides are all the same. Or C, no, each side is parallel to the side adjacent to it, and the lengths are all the same. Okay, so we either have parallel adjacent sides or perpendicular adjacent sides. And adjacent sides are the ones that are touching. So AB's adjacent side would be BC. So let's just check, do they have perpendicular or parallel slopes? So AB, is it perpendicular or parallel to BC? So AB's slope was 3/2, and BC's slope is -2/3. So parallel, are they the same slope? No, so they're not parallel. Perpendicular, do they have opposite signs? Yes, and are they reciprocals? Did the numerator become the denominator and the denominator become the numerator? Yes, so they are opposite signs and reciprocals. So yes, they are perpendicular. And then by observation, let's go through the other sides. So is BC perpendicular to CD? Are they opposite signs? Yes. Are they reciprocals? Yes. The 2 became the denominator and the 3 became the numerator. So yeah, we have perpendicular there. So then is CD perpendicular to DA? Are they opposite signs? Yes. This one's negative and that one's positive. Did the numerator become the denominator? 3 became yes, and the denominator became the numerator. Yes. So the 3 in the numerator became the denominator, and the 2 in the denominator became the numerator. So yes, they're perpendicular. So we have perpendicular adjacent sides. So we have a yes, and each side is perpendicular to the side adjacent to it, and the lengths are all the same. So yes, each side is perpendicular to the side adjacent to it, and the lengths of the sides are all the same. Alright, so there's question 6. And then we'll just talk through question 7. Is the quadrilateral EFG a rectangle? Okay, so in order for it to be a rectangle, what are the requirements? That's what we have to know. So let's look through the options for answer B. Yes, the quadrilateral has 2 pairs of opposite sides that are parallel, and all of its interior angles are right angles. Or no, the quadrilateral has 2 pairs of opposite sides that are parallel, but not all of its interior angles are right angles. Or yes, the quadrilateral has 2 pairs of opposite sides that are perpendicular, and all of its interior angles are right angles. And no, quadrilateral has only 1 pair of opposite sides that are parallel, and not all of its interior angles are right angles. So we're looking again for either parallel opposite sides or perpendicular opposite sides. In a rectangle, if you go back to your using perpendicular lines in coordinate proofs, and you go to the examples, I'm going to just click show all really fast just to talk you through how you could find out what do they need in order for it to be a rectangle. And if you come back and you scan through here, we need concept C, so I'm just going to keep going till I hit concept C. And then it's right here. Remember that in order to prove a quadrilateral is a rectangle, we must show that it is a parallelogram with 4 right angles. All right, so in order for it to be a parallelogram, it has to have opposite pairs be parallel. And for right angles, that means the interior angles have to be 90 degrees. So when you're coming here, I would write that in my notes. In order to prove a rectangle, it has to have opposite parallel lines, and the inside angles all have to be 90 degrees. So when you come here to question 7, yes, the quadrilateral has two pairs of opposite sides that are parallel, and all of its interior angles are right angles. That, or we're going to look for the no of it. So you're looking for opposite sides that are parallel and interior right angles. So that's how you would go back and check, okay, what do I need in order to prove a rectangle? And you need opposite sides that are parallel and all of the interior angles being a right angle. So check for parallel, that means check the slopes, and all of its angles being a right angle, that means check to see if adjacent sides are perpendicular. So we're only comparing slopes in question 7.